Okay, welcome to the video tutorial for the Unit 4 homework packet. We're going to look at the first 2 pages in the packet today. This is a reminder that a lot of what we're doing this unit is similar to Unit 3, and that the almost right answer is wrong. Okay, so taking a look, ionic formula review. This was all Unit 3. Okay, this Unit 3 stuff never goes away. So formulas are always our 4-step formulas. Okay, symbols, charges, crisscross, and then reduce and erase. Okay, so looking here, I like showing my work because otherwise I'm almost right, which will make me wrong. Okay, so manganese 4 oxide, the first step is symbols. For manganese, it's Mn. Oxide isn't on your polyatomic list because it's just oxygen. Okay, so those are my symbols, and I'm going to show my work on this side. Manganese oxide. Okay, that's symbols. Next is charges. It tells me in the name, manganese making a 4 charge oxide. So that's, my switch colors, is my metal charge. And then oxide, you need to remember your charges, your oxidation numbers. Okay, oxygen has 6 valence electrons. Nonmetals need negatives. So oxygen needs 2 negatives to be like the noble gases. So it's going to make a -2 charge. Okay, symbols, charges, crisscross. Okay, and then that would be a garbage answer because I can reduce it. Anytime both subscripts are even, you cut them in half. So instead of Mn2, it's Mn1, and 1s are invisible. 4 divided by 2 is 2. Manganese 4 oxide. Okay. Silver chloride. Silver is Ag. Chloride, I-D-E, is not on your list because it's just chlorine. Okay. Silver is in the 1B exception block, so you're supposed to know that it's the one that always makes a +1 charge there. And chlorine is a nonmetal that needs 1 negative to be like the noble gases. So they both make 1 charges. Symbols, charges, crisscross, reduce and erase. AgCl. Now we need to make sure we're not being almost right, because the next one we're going to look at is beryllium chlorite. Okay. Beryllium is Be. Chlorite is not chlorine. Chloride, I-D-E, is chlorine. Chlorite, I-T-E, is ClO2 minus 1. Okay. So beryllium chlorite, ClO2. Okay, and it makes, switch colors, a -1 charge. Okay. Beryllium is in the 2A family. Metals are messy, so they lose their valence electrons. It will be more positive by 2. Symbols, charges, now we crisscross. Okay, so I stay outside of those parentheses. It's a nightmare in there. Don't go in there. Be invisible 1. Let me switch colors again. Now I'm going to include my parentheses, ClO2, 2. Okay. Hopefully we're really good at this from Unit 3, because this never goes away in chemistry. Okay. Ionic naming. You need to check for Roman numerals when we're naming ionic compounds. So GaOH3, Ga is gallium, and it's in the exception block. So it always makes a 3 charge, which means no Roman numeral. And OH is hydroxide. So that's what I call it. Gallium with no Roman numeral, hydroxide. Nice and easy. Okay. Iron doesn't always make the same charge. It's not in the exception block, so it needs a Roman numeral. I'm going to call it iron blank. And nitrogen, we make nitride. Iron needs a Roman numeral, so making a blank charge, nitride. I-D-E. Okay. Now if I had to guess, I would guess that iron is making a 1 charge. because that's what's crisscrossed. However, I know that nitrogen actually needs 3 negatives. Okay? So if nitrogen needs 3 negatives, iron must be giving away 3 electrons if they're bonding 1 to 1 like this. So this iron is making a 3 charge nitride. Roman numerals give people headaches, I understand that. But they don't go away. So you've got to learn them. Come in for tutorial help. Okay? People actually pick them up quickly once they stop being afraid of them. This one's huge. This is what we're doing. Okay? Top half was review from last unit. Bottom half is comparing with our new unit. So which of the following is not, I'm going to circle my keyword, an ionic compound. Okay. You're going to make this foldable, this unit, if you haven't yet. Ionic versus covalent. Ionic compounds are always a metal plus a nonmetal, at least one of each. Covalent compounds are only nonmetals, which means that metal is your big indicator if it's ionic. So that's what we're looking for. Which of the following is not ionic? Which of the following does not have a metal? So K and F, potassium is a metal. It's on the left-hand side of the periodic table. So this one is ionic. Metal, nonmetal. Aluminum's a metal and nonmetals. Carbon and oxygen are both nonmetals. So that does not look ionic, but I'm not done until I take out the garbage, right? Gallium is a metal bonded onto OH, which are nonmetals. So A, B, and D are ionic. C is not ionic. That one would be our covalent one. Okay, question 13 gave people fits on the test. There was a question just like this on the Unit 3 test, and there will be moving forward, so I want you to see how we should do it. This is a classic take out the garbage answer. Okay, a student tests a pure substance in the lab and find it's not a conductor, okay, does not conduct electricity, has a low boiling point, does not dissolve in water. What type of material is it? Okay, so we need to look at this part. Right? If it doesn't dissolve in water and it doesn't conduct electricity, that means it's definitely not a metal. I can get rid of that. Okay. And then we did in our notes today on pages 2 and 3 that ionic things do dissolve in water often. So if it does not dissolve in water, it's probably covalent. Okay. And then question 16, which of the following is a covalent compound? This is the exact same question, literally, as question 11. Which of the following is not ionic means which of the following is covalent. So if it's metal, nonmetal, those ones are ionic. That makes this one my covalent. Okay, I wanted you to see they're worded differently, but it's the same question. All right, turn it over with me. Identifying as ionic or covalent. It's ionic if it is a metal plus a nonmetal. Okay, if it's got at least one of each, it's ionic. If it is only nonmetals, then we're covalent. So I'll look at just a couple of these with you. Okay? And I don't know how much of the periodic table I can get on here. But nitrogen and oxygen, both nonmetals, so covalent. Bromine and fluorine, both nonmetals. Sodium, way over here on the metal side, and iodine. So one of each makes this one ionic. Iodine and fluorine, covalent. Calcium, again, way over here. It's an alkaline earth metal, so that makes this one ionic. Sulfur and oxygen, both nonmetals, so this one's covalent. Okay. We need to get good at picking those out because ionics and covalents are named with different sets of rules. Okay, so if you can tell which is which, you know which rules we're going to use. Okay, on page 2 it tells you to use your notes. Okay, you don't have these memorized yet. It's Unit 4 notes from today, pages 2 and 3. I want y'all to check them. I'm not really going to do all these yellow ones with you. You'll look them up. Okay, but this one has 2 blanks. Conducts electricity when melted. Okay, we know metallic things conduct electricity. And in your notes today, we learned ionics conduct electricity when dissolved or melted. Okay. So most of them only have one answer, but if there's two blanks, it's because there's two answers. Look the rest up in your notes. If you were absent, then check your teacher's Canvas page for the notes that you missed. Okay. And then down here, we're just going to look at a couple of these. Okay. Transfer electrons. Okay. Ionic. I like to say that ionic is hiding the T for transfer in its name. And for covalent, sharing is caring. Covalent molecules share electrons, and ionic compounds transfer them. So for my Venn diagram, I'm going to say transfer is only ionic, and I'll say electrons, E-neg. Okay, so I did that one. Share electrons is definitely covalent. Sharing is caring. Share electrons. Okay, and a bond between elements, right? They're ionic bonds and covalent bonds. So bond between elements. And let me make sure I'm not lying. Dun, 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 dun. This is the only one that is both of them. Okay? Everything else is going to be either ionic or covalent. Thanks, y'all.